Today we're going to look at conditional statements. Rules of logical reasoning involve a set of given statements along with a valid argument to reach a conclusion. Statements to be proved are often written in if-then form. So our first vocabulary word for today is a conditional statement, and that's a statement that's written in if-then form. In other words, if some condition is met, then something else is going to happen. Okay? My example is I have two angles that are a linear pair are supplementary. Okay? This statement can be rewritten as a conditional statement. If two angles are a linear pair, then they are supplementary. So I'm using the condition that my two angles are a linear pair, and that results in the fact that they are supplementary. Okay? So let's rewrite each of these statements as a conditional statement. The first one, an angle that is acute will have a measure between 0 and 90 degrees. So what condition are we wanting to have met? We want the angle to be acute. So I'm going to say if an angle is acute, then what do we know is going to result from that? Then its measure is between 0 and 90 degrees. Okay. Notice I have an angle is acute, then its measure is between 0 and 90. So I know up here that I'm talking about an angle. It's real tempting for us to sometimes say, if it's acute, then its measure is between 0 and 90. But that's not a complete sentence because nowhere do I have an actual subject, right? So make sure in your hypothesis you never use words like words like it's, they, their. Never use something vague in the first part that comes after the if. You can only use words like it's, they, their when you are in the second part after the word then. Okay? When I look at the next one, it says x equals 4 implies x squared equals 16, because if x is 4, right, then when I square it, I'm going to get 16. Well, did you hear it? I just said it. If x is 4, then x squared will equal 16. Right? Because 4 times 4 is 16. All right, so if x equals 4, then x squared equals 16. Okay? All right, and then my last one here, a polygon with 4 sides is a quadrilateral. So remember, polygon is just a shape that's closed and made with straight segments. So a polygon that has 4 sides is a quadrilateral. So my condition that needs to be met is I need to have a polygon and it needs to have 4 sides so I know what to call it, right? So I'm going to say if a polygon has 4 sides, then what happens? Then we know it's a quadrilateral. So then it is a quadrilateral. And I don't have to say then the polygon. I can say here on the second part of the sentence, then it is a quadrilateral. Okay? So a couple more vocabulary words today. The first one is hypothesis, and your hypothesis is the if clause of a conditional statement. Okay? So the hypothesis is the clause that comes right after the word if, but before the word then. Okay? Our second word is the conclusion. My conclusion is the then clause of a conditional statement. So it comes right after the word then and is the rest of the sentence. Okay? So here's an example. It says, from the conditional in the first example, if two angles are a linear pair, then they are supplementary. Remember, that's the one we did up here, so we're just staying with that one. We're going to identify the hypothesis and the conclusion. So your hypothesis is everything that comes after the if, but before the then. And it doesn't include the word if. So two angles are a linear pair. Okay? That is my hypothesis. Two angles are a linear pair. Notice on my little note down here it says the word if and then are not written as part of the hypothesis or conclusion. Notice I did not start with the word if. Okay, I made this blue part, the hypothesis, I made it its own little complete sentence. Two angles are a linear pair. Okay, notice this keeps going on. It says each is written as a complete sentence. That's important, especially when we get to the conclusion, because if I just write the conclusion, they are supplementary, then I don't know what they are anymore, right? In the sentence up here, in the conditional, it works because I know what they is referring to, right? It's referring to those two angles. But if I just write just the conclusion all by itself, they are supplementary. What are supplementary, right? I don't know what we're talking about. So I have to say, what is they? They are the two angles, right? So my conclusion is the two angles are supplementary. Okay, so that I have a subject, right? I don't have a subject if I just say they are supplementary. I don't know what I'm talking about. Okay? All right, so let's practice this with some mathy type things. It says conditional statements are often used in mathematics. We have if 3 times x plus 2 minus 1 equals 5x plus 11, then x equals negative 3. We want to identify the hypothesis and the conclusion. So remember, your hypothesis is everything not including after this, or if, until you get to then. So my hypothesis is 3 times x plus 2 minus 1 equals 5x plus 11. That's my hypothesis. My conclusion is everything that comes after the word then. X equals negative 3. Okay? Again, notice I did not use the word if in my hypothesis, and I did not use the word then in my conclusion. Okay? All right, in the next video, we're going to go ahead and continue this, and then we're also going to see where some counterexamples come into play when working with conditional statements. All right, thank you so much for watching.